Welcome to the channel. So what you see here is a full-on bipedal robot. I only got the one leg working right now, but you know, it's progress. What I want to do is have a high power to weight ratio robot that actually walks just like a human would. That's no small task, and we will discover that together here in the next few videos. But please subscribe and hit the bell and to keep up with the channel here. I'm going to be releasing some videos to show my progress. So far, it's a little wobbly and needs a bit of improvement, but this is what I got. You can probably see that when the computer was telling it to move to a certain position, that it didn't actually reflect that in real life. A lot of that has to do with the fact that the scale in the computer program isn't the same as the scale in real life. It's not a hard fix. It just takes a lot of trial and error to get that done. And then you could also see that there's a little bit of wobble. I think a lot of that has to do with the stand. Right now it's kind of on a diving board setup, stuck way off on my counter here, so it's not the most secure. So, and also the Lexan does allow a little bit of flex. So we'll see what actually happens when I take it off the stand and take it for a spin. But I only got the one leg working for now, and hopefully the next leg will be working here in the future. I'm waiting for some parts, but I just wanted to show you what I got together so far. So this here is going to be where the motor is going to mount. It's going to kind of stick out a bit. I'm not really super pleased with the idea, but the design does work. So then this thing will come out like this, and it will also pivot. But you could see that it's kind of hit my stand here, so I can't come out all the way. And then of course it does come all the way out like that. So as you can see here is the robot. All these motors here are all brushless DC motors, and they're all controlled with belt drives. You get almost no backlash, and you can swap out different combinations here to change your gear ratio. This is the encoder here, and these ones up here, because they need the extra strength here, they're controlled with ball screws. And then down here, I'm going to try to get away with just cheap threaded nuts. And here's all the O drives. There's no fans on them yet. There's fans on all the motors here, but that's just as needed type basis. I'm also controlling everything, using thrust bearings. I kind of made my own custom 3D printed thrust bearings, and I just embedded these little cavities. These are spears that actually snap in metal beads or balls, into those things, and then they will captivate the ball and then work as thrust bearings. So they're cheap and easy to do on the 3D printer. And then everything else is just cheap bearings. This little lever mechanism here, that is to make it so that you have a shorter distance of travel for that one piston, and then that will help quite a bit in the size of the piston that you need to put in there. Of course, it's going to require more torque. And then this other one's pretty basic here in the knee. And then the foot, you should be able to turn it in almost every direction here. SolidWorks really doesn't like that, but anyways, you could easily, see, SolidWorks doesn't like it. But anyways, you could turn it around in almost every direction, just like a human foot. So that's pretty cool. There's universal joints here. You can see on the real robot, I don't have it modeled. But anyways, I'm not really too happy with the ankle design yet. It's just a prototype. But yeah, anyways, that's the gist of it. Looks like I broke his ankle here. Yeah, anyways, thanks for watching, and please subscribe, hit the bell, and I'll post some more videos. Anyways, see ya. Bye.